transforming sine waves, okay? And not just any type of transformations. We're going to specifically only work on two, horizontal and vertical transformations. Now, I want to draw your attention to this. Now, I've written it as y, and we are used to f at x. But I want you guys to see the similarity of this between f at x is equal to x minus what? What normally goes in here for parabola? H. Okay. And in this one, we'll move the other one down too. That's right. What does each of those deal with? X squared plus k. So, which one deals with horizontal shifts? H, okay? Which in this case is going to be our C, okay? So in other words, when we have a number inside that bracket with a sine function, we're going to be shifting this horizontally, okay? And which one deals with vertical shifts? K, or in this case, for our sine function, it'll be D. This is going to deal with vertical shifts, okay? The ideas are identical to parabolas. So if our C function is positive, what direction do we go?
Left.
Left, right? We go in a negative direction. If our C value, and that is including both, the entire term, okay, is negative, we go to what direction?
Right.
Good, nice and easy. In this case, if D is positive, what do we do? Up. Okay? And when D is negative, down. Very simple, very similar to parabolas. In fact, it's pretty much identical. Okay? So we're going to practice a couple of these. It's very important, though, in order to draw these, just like when parabolas, you had to know how to draw y equals x squared. You must know how to draw y equals sine x. You need to have the ability to create the original wave. So we're going to put one up here. All right, so we put up a graph. Very important that you notice I put up a trigonometric graph. In other words, this is in degrees. I focused on some major points, and we could do these in ones if we wanted. But remember, because a sine wave's period is 360 degrees, I got to make sure my graph at least shows one period when going through this. So I've essentially focused on 90, 180, 270, 360, and gone by there. So essentially I went up by 90s. And if you get really specific, each unit is technically 45. But the reason we've done this, and I'm going to recap with this, you need to know how to draw this function. So what is the very first point? I'm at the origin, x equals 0. What's my y value?
0.
0. Okay, so that's one of the major points you need to know for the normal sine function. 0 and 0. Then I'm going to jump to 90. What is my y value when x is 90? 1. Okay? So in other words, I have 90 degrees and 1. The next major point here is 180 degrees. What is my y value? 0. Good. What's my next major one?
-1.
But what's the x value? 270 degrees. Good. Value of y?
-1.
Good. So there's our -1. And then the last one?
360.
360 and 0. Good. Those 5 major points complete a cycle or a period here. Okay? So, as long as we know how to sketch that, we can continue this pattern to the right and the left. So obviously the next point here at 450 would be 1. If I was going backwards, -90 is -1. 180, 0, -270, 1, 0, and negative. So just like on your quiz, just like on your quiz, you need to know how to continue this pattern. So, our original sine function we have. The black wave represents y equals sine x. So, we're going to put in 2 other ones here. Let's say we had y was equal to sine x plus 2. Okay? Sine, that should be, there you go. Sine x plus 2. First of all, which is that dealing with? Is that dealing with vertical or horizontal shifts? Is this a D? Okay, let's think of it this way. what I've written here is y equals sine x plus 2. So what letter does this deal with?
D.
D, that's right. Y equals sine x plus d. D dealt with what, Khalil? Good. So, because it's positive 2 and we're dealing with vertical, either up or down, which direction are we going? That's it. We're going up 2. So really, all I need to do is take each of the major points and transform them up 2. Now, if you look, that's 1. This would be 2. Okay? 1, 2, 1, 2, 1, 2, and 1, 2. I've transformed the 5 major points. Okay? I've moved them all up 2 units. And all I really have to do is, like in kindergarten, connect the dots. From there, I can probably continue my pattern, which I'm going to need to do. There we go. So we continue this pattern. And there we go. So this is our y is equal to sine x plus 2. All it is a vertical shift up 2 units. Had that been negative 2, what would we have done? We would have just taken those 5 major points and moved them all down 2, and we would have had something like this 2 units below. Okay? Since we have that, let's go with the last type of example. What if I give you a question that says y is equal to sine x minus, this would be a tougher one, 45 degrees. First of all, am I dealing with vertical or horizontal shifts? Horizontal, right? What letter does that negative 45 stand for? C, right? We had sine x minus c. We're dealing with horizontal. Since it's negative 45 degrees, what direction and how far are we going?
Horizontal 45 degrees.
Horizontal which way? To the right. Okay. We're going in a positive direction. So we're going in a positive direction, 45 degrees. So, let's go look at that original one again. 45 degrees to the right. I'm going to take all these 5 major points. Now, luckily, my graph, each of the units is 45. Okay? So, I'm moving this to the right, 45. To the right, 45. So, each of those 5 major units have been moved 45 degrees. So, if we take a look at this now, it's going roughly the same. Okay? The pattern becomes the same. The only difference is everything has been shifted to the right 45 degrees. So this one would actually not even exist. Okay, so we continue this pattern. It looks pretty good, eh? So essentially what has happened is we've moved everything to the right 45 degrees. That's pretty much the entire lesson tape. We're going over just those 2 things.